So now today we are seeing about the concept of partition technique. So let us see with an example. So this is an example given for you. So in this example we got six present states as well as two input conditions x equal to 0, x equal to 1, and for this we are having the how these states are behaving under x equal to 0 and how these states are behaving under x equal to 1. So this is the given condition and they ask you to reduce the number of states. See, actually this partition technique is nothing but this is a technique which is used to reduce the number of states in a given state table. So as we are having six present states, at the final end or the final step we need to get some minimum number of states. That means total in the given question they have six. We need to reduce into 5, 4 or something, whatever it may be. We need to reduce the number of states by using this technique. So partition technique is a method which is used to reduce the given state table into minimum number of states. Okay. So if this is the given question, then how to proceed the concept here? First step number 1, from the given table you need to observe for which states of the how many states are having a common functionality with respect to outputs. Okay, see, suppose if you consider the concept of A, the state A is having output 0 under x equal to 0, the state A having output 1 under x equal to 1, right? That means under x equal to 0 A is producing output 0, under x equal to 1 A is producing output as 1. Likewise, the same functionality wherever existing, you verify that. See, say C also having output 0 and x equal to 0 and having 1 at output equal to 1, sorry, input equal to 1. In the same way, state E, output is 0 and x equal to 0, output is 1 and x equal to 1. That means in the first step what you do is you need to separate all these states into several groups depending on the output. See here, separate by regarding the output under x equal to 0 and x equal to 1. So the first step is nothing but with the help of outputs we need to segregate into several groups. See here, A, C and E. A, C and E contains the output as 0, 1, 0, 1, 0, 1. Similar outputs. That means the operation is same regarding the outputs in the case of A, C and E. If we observe B, D and F, here also see here the state B, it is generating output 0 and x equal to 0, output 0 and x equal to 1. That means x equal to 0 or x equal to 1, output is 0. Likewise, you can find in the case of D. Likewise, you can place in the round of F. That's why A, C, E are performing the same operation regarding outputs. B, D and F are performing the same operation regarding the outputs. That's why A, C, E will be the one group and B, D, F will be the one group. So the first partition is nothing but you need to segregate into groups. Partition, right? So among these six, regarding first step, A, C, E will be first group. Why? Because their operation will be same regarding the outputs. That's why A, C, E will the first group. In the same way, here B, D and F are producing the same operation. That's why B, D, F will be the second group. So the first part is nothing but it consists of two groups. First group is A, C, E and second group is B, D, F. So likewise you need to segregate the first partition. Clear? And now how to do the second partition. Now if you come under second partition, first of all you need to note down all the groups present in the previous partition. Now we are doing the second step. So previous partition means P1. So P1 will consist of two groups. One group is ACE group and second one is PDF group. So write down these two groups. Okay. And now for each and every group you need to find 0 successor and 1 successor. In the previous session I have said a definition of successor. That means if A is moving to B, for an input 1, then B is called as one successor of A. Likewise, you need to find out the successor. So from the given state table, you need to note down the successor values for ACE and BDF for all the groups present in the previous partition. For all the groups present in the previous partition, you need to find 0 successor and 1 successor. For this also 0 successor, 1 successor. So how to find this? So when you observe this state table, the table here, see ACE. Now I need to find 0 successor. How to find it? It means that state A, when input is 0, where it is going. That is the condition. The state A, when input is 0, it is going to state E. And that I written here, state E. The second state, state C, when input is 0, where it is going. State C, when input is 0, it is going to E. Again I written E here. And next, state E, when input is 0, it is going state C. So again I written state C here. That means the states A comma C comma E, when input is 0, they are moving towards these respective states. Likewise, A comma C comma E, when input is 1, one successor means when input is 1, where they are going. So A state, see here, the state A, when input is 1, it is going to D. That's why I written D here. Next, the state C, when input is 1, it is going to B. That's why I written B here. And next, third state, state E, when input is 1, it is moving towards F. That's why I written F here. Likewise, you need to find the 0 successors and 1 successor. In the same way, for this also, B comma D comma F, you need to find 0 successors and 1 successor. BDF, BDF for 0 input, where they are going. B is going to F, D is also going to F, F is going to B. So F comma B, F comma B. And these same states, when input is 1, where they are going. D comma B comma C. And written here D comma B comma C first. Right? And now how to simplify this? See, the 0 successor and 1 successor values are these two for the first ACE group. These two are the 0 successor values and 1 successor values. Now you need to verify these two groups whether they are existing in the similar way in the previous partition or not. That means here you can write as E comma C. These two are same state, so you can write as E comma C. Whether E comma C exist in a same group in the previous partition or not. See here, E comma C existing in the same group in the previous partition. Now we are in P2. Previous partition is P1. In this P1, E comma C exists in the same group. So no problem for us. So I have put tick mark here. Next step. 1 successor values D comma B comma F. All these three should exist in a same group. See here, B comma D comma F. So no problem. That's why I put tick here. When both the conditions are in tick mark, that means both are satisfied, then no need to segregate this. No need to make partition of this. That's why I written directly in the P2 here. Okay, directly written P2 here. See here, both are satisfied. That's why I didn't make this partition. Okay, directly written the same group in the answer P2. And now the same concept you go for this one, F comma B. That means F comma B should exist in a same group in the previous partition. See here, F comma B existing in the same group. That's why no problem. Put a tick mark here. And now come for 1 successor, D comma B comma C. Here it is very important. D comma B comma C. D comma B existing in one group, C is separately existing in another group. These three are not existing in the same group. These two are in one group and this C is separately in one group. So here the condition is not satisfied. Right. Remember that when both 0 successor and 1 successor are satisfied like this, then only you need to write directly like this. If any one of these two is not satisfied, you should not write directly here, and you should make here partition. See, D comma B existing in a same group, where C is existing in separate group, and this C is the answer for which one? F, right? See here, see here, C is the one successor of F, right? That's why this C is separately written in the answer. See here, sorry, this C is the answer for F. That's why this F is separately made as a group and B comma D as a group. That means because of this unsatisfying condition due to the C, where C is the answer of F, we are making this F as a separate group and BD will be separate group. That means we are dividing this BDF into two groups, B comma D as one separate group and F as one separate group. This will become your second partition. Okay, remember that when both the conditions are satisfied like this, then directly write the answer here. Directly write the group. If any one of these are not satisfying, then C for which letter it is not satisfying or for which state it is not satisfying, and that state is separately written in a group. Right now we are having P1, P2 right now. Now how to write P3? The same process. Now forget about P1, go with P2. Okay, now this is our previous partition. We are in P3 now, that's why this will become our previous partition, not P1. Forget about P1. Now we are in P2. Now how many groups are there here? 1, 2 and 3. 3 groups are there. Same process. For each and every group we need to find 0 successor and 1 successor. 0 successor and 1 successor. And you be careful that in a partition, a group with single state like this, a group with single state is directly written in an answer. You can directly copy that state. You don't need to find 0 successor, 1 successor. If a group with a single state directly written into your answer P3. Okay, now we have only two groups like this. Same process, ACE, 0 successor is E comma C, 1 successor is D comma B comma F, right? And BD, 0 successor is F comma F, 1 successor is D comma B. Okay, successor means nothing but A input 0 where it is going, C input 0 where it is going, E input 0 where it is going. Likewise, you need to note down the states. Here also, A when input is 1 where it is going, C when input is 1 where it is going, E when input is 1 where it is going. Here also, B when input is 0 where it is going, D when input is 0 where it is going. You can see the state table in the given question and you can copy the same values here. Okay, now you verify these whatever groups you got with previous partition. What is previous partition now? As we are in P3, P2 will be the previous partition, right? Now see here, first E comma C, whether E comma C existing in the same group. See here, E comma C existing in the same group, so condition satisfied here. Next, D comma B comma F. See here, D comma B is lying in one group, F lies separately. That's why this condition is not satisfied. D comma B comma F, all the three should exist in the same group, but we don't find in the previous partition like that. We find that D comma B existing separately and F is existing separately. That's why this F is responsible for the term E. F is the answer for E. That's why make this E separately in the partition. Make this E separately here. When E is separated, these two will be remaining, AC. That will be lying in the one group, AC. Now AC is separately and E is separately. Already this F is copied directly here. So now the answer will be AC, E and F right now with us. Now we need to verify this BD also. So F comma F, that means a single F. Already single F present here. So condition satisfied. D comma B existing in the previous state. condition satisfied. As both are satisfied, we no need to make partition here. Directly you can write this combination here. Okay, so therefore P3 will be A comma C, B comma D, E and F both are single groups, single state groups. Okay, so likewise you can do with P3. Now what you need to do? You need to go for P4. That means as the so in the previous partition we got this as your final answer P3, and now we are moving to step 4 P4. So in the P3 you find here 1, 2, 3, 4 groups here, right? So among these 4 groups we are having 2 separate groups which are having single states. So directly write that in your answer P4. See here E comma F. I written in here E comma F. Same I brought this in the answer. Why? Because a group with single state, no need to find like this. Directly you can write the answer. And when you remove these two, you have only these two groups. I written here AC, BD. Again I found 0 success, 1 success, 0 success, 1 success. I got these answers. Now I have to verify these groups with respect to previous partition. I am in P4. Obviously P3 will be the previous partition. E comma E. That means a single E. Single E already exist here, so no problem. Next D comma B already existing in the same group, no problem. Next F comma F, that means single F present here, no problem. Next D comma B, so no problem. So all are satisfied, so I no need to do again any partition. As these two are satisfied, directly write AC here. As these two are satisfied, directly write here. So when you observe this P3 and P4, both the partitions, how the answer of these two, whatever you got in P3, the same you got in P4, right? So the condition is, so you need to you need to continue the process until you got two similar partitions. That means you need to continue the process, go on, but two successive partitions should get same output. See here, P3 output is same as P4. Whatever the groups you got in P3 is the same you got in P4, and hence see here, as P3 equal to P4, we are stopping the process, and now this will be the final partition. So this will be the final partition. Okay, and now in the final partition we are having four groups. In this, these two are what we say, a single state groups. We don't have to bother this. When you come to these two, we are having groups as AC and BD. It means that A equal to C and B equal to D. Okay, in the final partition, if we have groups like this, AC and whatever it may be, groups like this, it means that A equal to C and B equal to D. That means in the finalized table, either you can eliminate A or you can eliminate C. Why? Because both are same. You don't need to write both. Any one you can eliminate. That's your wish. Here also P is equal to D. You can eliminate D or you can eliminate B. That's your wish. Okay. So I am writing here. It means that A equal to C and B equal to D. So therefore the reduction table, the reduced table or minimized table will be again you need to draw. Okay, and that will be an very important, that final table. So see here, as the states A equal to C and B equal to D. As I said that both A or C both are equal and B or D both are equal. So you can eliminate any one of these two. Either you can eliminate A or eliminate C, or you can eliminate other. That means among these two you can eliminate any one. Among these two you can eliminate any one. I am eliminating C from the first group and I am eliminating D from the second group. Okay. And now how to write the final answer, final table. That is the very important. See here. So this is the given question for you. This is the given question. So in this given question, I said that I am eliminating C. That means this C should not be present. This state you need to erase this state. Okay. Simply don't erase. You draw a neat. Again you draw a table. In this table you no need to include this row C. C is eliminating here. In the same way I am eliminating D also. So this D is also eliminating here. So in the final table I will have only A, B, E and F. C comma D will be eliminated. So these two rows should not be included. And there will be one important factor. As we are eliminating C comma D, in the final table we no need to see, we should not see any other states like C comma D. See here, if we eliminate these two, suppose for example, if we eliminate these two, the final table how it will be? So this will be the final table. So like this the final table will be C and D I erased completely. Now you will have only the state A, state B, state E and state F. As C comma D are eliminating, we should not find a letter C comma D in the final answer. But see here, you are having a C here, you are having D here. As we are eliminating C comma D, those states should not exist actually. See, but we are having C here and we are having D here. Then what we can do? As we concluded that state A equal to state C, right? So in the wherever you find C, you can replace A there. You can write as A equal to C, you replace all the C letters with A. When after removing the states C comma D, then you replace any other C present in the table, final table. If at all, if there C is there, you can replace with A. In the same way as B equal to D, wherever you find D, you can replace with D. Right? Therefore, the final table will be like this. Sorry. See, the final table will be like this. In this final table, you don't find any letter like C comma D. Why? Because we eliminated those C comma D. Clear? So this will be the final table. Okay, like this we need to write the final minimized table. In the given question we got 6 states and now we got only 4 states. So likewise we need to reduce the number of states by using this partition technique. Okay, so partition technique is nothing but the technique which we are using to reduce the number of states in the given question. So how to do